Mastering Data Accuracy and High Mark Exam Strategy for Cambridge IT 9626. We are jumping straight in today because there is a massive trap catching out thousands of students, and we need to fix it right now.
Listen to this statement. Validation ensures the data entered into a system is perfectly correct, true or false. This is a flawed definition that pops up on exam papers all the time. Have you ever written something kind of like this?
Well, if you said true, I'm afraid the answer is completely false. And this one tiny misunderstanding literally costs students an entire grade boundary. Thinking validation guarantees correct data is the absolute #1 mistake that bleeds marks. Because the second you write this, the examiner immediately knows you don't actually understand the fundamental concept of data accuracy.
Section 1, the costly exam mistake. Let's dismantle this mistake right now and rebuild your understanding to match the exact framework the Cambridge Mark Scheme is actually looking for. Here is your golden rule. Validation is simply a computer checking if data is reasonable and sensible. Verification, on the other hand, checks if that data was accurately transferred or typed in, regardless of whether it actually makes any sense at all. They are two completely different defensive walls in a database. And this brilliantly illustrates why validation just cannot guarantee perfection. Imagine someone mistakenly receives an electricity bill for $321 instead of their actual usage, which was only $231. A validation check won't catch this error because $321 is still a perfectly reasonable and sensible amount for a utility bill. Validation just says, yep, this number fits the rules. It does not say, yes, this number reflects reality.
Section 2, Interactive Exam Challenge. Now that we have those definitions locked in, let's apply this examiner's lens to a practical Cambridge-style scenario directly from the source material. Look at this books database table. Notice the data types and the natural limitations of the information. For example, look at the cost column. The prices range strictly between $10 and $29. An examiner will expect you to look at a table exactly like this and immediately spot that a range check would be perfect for the cost field, ensuring nobody types in a value lower than 10 or higher than 29.
Now check out this connected borrowers table. Pay super close attention to the specific formats. See the borrower ID? It includes leading zeros. That means it must be set to an alphanumeric data type, otherwise those zeros would just vanish. And take a close look at the class field. You see entries like 11D and 10A.
So here is your pause and predict moment. If an exam question asks you to choose and justify the most precise validation check for that class field, like 11D or 10A, what specific check gets you into the top band for marks? Think about it for a second.
Okay, you would secure maximum marks by suggesting either a format check or a lookup check. A format check, which is sometimes called a picture check, forces the user to type exactly 2 digits followed by 1 letter. A lookup check compares the entry against a predefined list of valid classes. Notice how I didn't say length check? A length check ensures it's 3 characters long, sure, but it wouldn't stop someone from typing in ZZZ, missing the format completely. Precision is absolutely everything here.
Section 3, Elevating Your Answer Band. And listen, in a moment I'll show you the specific examiner clue that changes the answer completely, but first, you need the framework that makes that clue obvious.
Spotting the right check is a great start, but how you explain its application on the paper dictates whether you get a C or an A. Notice the contrast here. A classic rookie trap is slapping a presence check on every single field when asked for validation methods. Examiners hate this. They want to see you apply it strategically to unique identifiers, like the borrower ID or the ISBN. Applying it to every single field is just inefficient, and it proves to the examiner that you don't really understand how databases function in the real world.
When you are asked to explain a concept like double data entry, don't just write a single weak sentence. Use this point, evidence, explanation, link framework, we call it PEEL, to construct an airtight answer. State the method, tie it to the specific database in the question, explain the actual mechanics of the computer comparing the files, and link it right back to the goal of accurate data transfer.
Let's look at how this applies to verification. This comparison brilliantly illustrates the critical difference examiners are hunting for. In visual checking, a human is manually spotting the error by looking back and forth between the screen and the source document. But in double data entry, the data is typed twice, and the software automatically compares the 2 versions, freezing the keyboard or alerting the user until the discrepancy is fixed.
Section 4, Mastering Complex Verification.
Okay, let's escalate the stakes.
Simple database checks are one thing, but Cambridge loves to test complex data transmission checks. When sending bytes of data across a network, say an ASCII character converted into a binary string of ones and zeros, we need a rock-solid way to verify it wasn't corrupted in transit. And that is exactly where the parity check comes in. It's a brilliant, highly logical system.
Examiners love asking you to step through this exact logic. For an even parity system, the sending device counts the ones in the byte. It then adds an extra parity bit to the end to ensure the total number of ones is an even number. When the receiving device gets the data, it counts the ones again. If it counts an odd number, it immediately knows a bit was flipped and an error occurred during transfer.
But parity checks have a fatal weakness. If 2 bits flip, the error goes completely undetected because the total might still be even. Plus, they're only for individual bytes. For transmitting whole files, you'll need to explain checksums to the examiner. A checksum uses a complex algorithm, a hash function, on the entire file data before it is sent. The resulting value is sent with the file, and the receiver recalculates it to ensure a perfect, exact match. For instance, if you mention the popular MD5 checksum algorithm in your exam, you can note that it produces a 32-character hexadecimal value. This 32-character string acts as a unique mathematical fingerprint for the entire file. If even one single pixel in a massive image file changes during download, that 32-character fingerprint will completely change. It's foolproof.
Section 5, the hidden mark trap. This brings us to our final and, frankly, most challenging concept. This is the hidden mark trap that trips up even the most prepared A-level students every single year. Imagine an exam question gives you this sample data. You have student IDs on the left and number of exam passes on the right. The question asks you to calculate a transmission total to verify the data was sent correctly. So, do you calculate a hash total or a control total? Here is the absolute secret to getting this right. A hash total adds up fields that have no mathematical meaning whatsoever, like adding up all the student ID numbers. The resulting massive number is totally meaningless except to verify the data. But a control total adds up meaningful numeric fields, like the total number of exam passes. This not only verifies the data transfer, but gives you a total that could actually be used to calculate a school average.
Understanding the definition of these checks is just step 1. But what happens when the exam paper throws a command word like evaluate at you instead of describe? That single word changes the entire mark scheme. Missing that clue is the hidden cause of lost top band marks. You might know all the theory in the world, but if you don't answer the specific command word, your grade will tank.
So look at your last past paper right now. Did you lose marks because you didn't know the answer or because you didn't know what the examiner was actually asking? To uncover the framework that decodes these crucial command words, you must click over to our next explainer right now, where we solve this exact problem. And before you do, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click the video on your screen right now and let's unlock those command words.